Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azan. I'm from College Universiti Sains, Universiti Sains Malaysia. I'm presenting to you polymer formulation used in carbon membrane synthesis and the performance evaluation. So basically, this is my PhD project, which is related to uh, carbon membrane production. So let's get to know about carbon membrane first. Right, so basically gas separation is very important chemical process. It is where we obtain our basic polymer products to put, and then we process furthermore to become the products for commercial use, right? Okay, so basically the main purpose of gas separation is for the removal of impurities in the gas streams or recovery of unreacted gases from chemical reactions. And another one is for purification of gas, right? For example, for medical purpose, which requires a high purity of oxygen for certain patients and for certain treatment. Okay, so basically there are several conventional process to do this. Right, the first one is cryogenic distillation, in which you lower the temperature, so the difference in the boiling point between gases is utilized to separate the gases. And then we have a pressure swing absorptions, and we have a amine absorptions. So amine absorption basically we use specifically for CO2, but in my case I use a membrane separation, membrane concept. So basically, membrane is a material. A material is basically it's a flat sheet, all right, which is used to separate gas, in which the membrane have very small pores. Okay, as you see that we have a large molecules of gas and we have a smaller one. So there are two different gas here. Okay, the small one will be allowed to pass through the pores of the membrane, and the large one is rejected. So basically, we have a uh, high purified gases, or this the objective of the separation is achieved through this concept. So uh, in my study, I produce a carbon membranes. There are many types of membranes. Carbon membranes is a membrane that are made of carbon, like charcoal. Okay, it's made of charcoal. It's like this charcoal, charcoal like wise, material wise. Okay, so there are others, like for example there are also other polymers membrane, ceramic membrane, and zeolite membrane. There are many types of materials that are used to make a membrane for to achieve certain separation objective. And in this case, we produce a membrane that are basically carbon. Okay, so basically in this slide, I'm going to review the formulation currently used in the literatures in the field of carbon membrane. So there are basically in any studies of carbon membrane, basically there are three steps. Okay, the first one is synthesis, and then we synthesis the polymer solution, all right, and then from the polymer solution we produce a polymeric membrane, and then from the polymeric membrane we convert into a carbon membrane through thermostabilization or pyrolysis, and then we perform permeability and permissibility tests, Barnier gas test, and diffusion analysis. So there are also characterization studies for this whole studies. Okay, so this is an example of, we have here a polymeric hollow fiber membrane. We produce it here, and then when we pyrolyze, we send for high temperature treatment. The polymer membrane, the membrane will be change in terms of size and thickness is due to the densification process from uh, polymer into a purely carbon materials. Okay, this is the forms of after the conversions, and this is, as you can see, the thickness is very different. Right. Okay, certainly the thickness, you can see the thickness is quite different. Okay, there's approximately around maybe a 10% reduction. Okay, so so that was the introduction, a little bit about the carbon membrane. So in the field of carbon membrane, there are many formulations used. There are so many polymers being used to synthesize carbon membranes to test their performance. And based on our literature survey, basically we can divide the carbon membranes into three types. Okay, based on the studies so far, right? So the first one, some researchers use pristine polymer or non-modified polymer. Uh, and then the second type is they modify the polymer first uh, through physical modifications such as additional of secondary materials or through chemical modification such as cross-linking process between different polymers or between polymer and other species. And the third type is the non-commercial organic materials. All right, for these are the examples that these are some of the examples that we collect based on our literature survey that the pristine polymer, most of them can be divided into polyimide and non-polyimide polymers. Okay, these are basically uh, the most of the materials being most of the polymers materials being used for the studies. And as you can see, the polyimide, we have a 6 FDA based polyimides. We have metrimide, we have tholon. So both of these, they are commercial polyimide that's being produced by other companies. By and then we have for non-polyimide, we have, for example, cellulose acetate, we have phenolic resins, and polyphenylene oxide. And for the modified polymers, we have uh, some of the modified polymer, for example, is polyamide with addition of zeolite, bromide, or other uh, addition of other polyamides. Okay, for example, metrimide and toluene, they mix together, they blend to each other, and then you also mix with other non-polyamides polymers. Okay, some of them also add some performers. Okay, add some material like metal like silvers. Okay, depends on the purpose of the the use of the carbon membrane and the separation. And for non-commercial materials, we can see that we have natural cellulose, coal, and cellophane papers that can be easily obtained from the market. Okay, so when we go further, we can see that there are a great distinctions, a great differences because there are widely there are there are groups that widely use polyimide as a precursor and non-polyimide as a precursor. Okay, uh, so basically this is about thermoplastic and thermostat division. For polyimide, they are popular to be used as a carbon ring because polyimide is a thermostat. It means that when you convert into the carbon membrane, when you treat the polymer at high temperature, you don't have to go for thermostabilization. It means that the thermostabilization is the function of thermostabilization is to prevent the polymer from melting during the increasing temperature treatment. Okay, so you can have a direct conversion to carbon membrane. However, it has a complicated synthesis and formulation, and is mostly expensive polyimide. Right, it's very complicated to synthesis polyimide. And non-polyimide such as polyphenylene, phenylene oxide, or PI, polyethylamide. Alright, those are uh, uh, cheaper, but they requires extra step in the conversion into the carbon membrane, which is they require thermostabilization. Thermostabilization is mean that they will heat the polymer uh, at their glass temperature with the presence of oxygen. for certain period of time, and then and after that they will proceed with pyrolysis. This is to prevent the hollow fiber, for example, from melting and become deteriorated. Okay, but the advantage of the non-polyamide, because they have a simple synthesis and formulation. Okay, you have the powder of polymer, you have the solvent, and you just mix and you stir. You have the polymer solution and ready for polymeric membrane synthesis. Okay, and they are also easily blended with other materials. Okay, how about their performance? As you can see, this advantage and disadvantage between the polyimide and the non-polyimide. So based on these uh, these figures, we have a wide axis of selectivity. Okay, the higher the better, and we have a hydrogen permeability virus. So this graph is about hydrogen nitrogen separation. Okay, we can see the distribution is quite fair. Okay, between polyimide and non-polyimide and modified polymers. Okay, it's quite fair. So because the hydrogen nitrogen separation is not that complicated, we can also produce uh, other types of membrane that's not as delicate, that does not have a delicate structure as the carbon membrane. Okay, because the separation is quite easy, because the diameter, the kinetic diameter between the hydrogen and nitrogen is quite big. The difference is quite big. So uh, so but as you can see, based on the distribution here, on the commercially attractive region, commercially attractive boundaries, we can see that uh, okay, uh, the non-polymer provides better performance and should be the main focus for further development. If you are interested in developing a carbon membrane, you should for hydrogen nitrogen separation, you should uh, you should survey non-polyamide polymers, and you can also have a modification to improve the separation, such as adding secondary materials such as palladium. Okay. This is about the this question is about oxygen nitrogen separation. So previously we discussed about oxygen nitrogen separation, hydrogen nitrogen separation, and this is the oxygen nitrogen separation. This is quite a popular separation, right? Because both gas is highly demanding oxygen, pretty highly purified oxygen and highly purified nitrogen. Okay, so as you can see that this is very competitive performance. If you can see that against each other, all right, which is you can see the polyimide polymers and non-polyimide modified polymers uh, quietly uh, competitive between each other. So this shows that non-polyimides are the most viable choice for the production of carbon membrane, because you don't need to go through complicated synthesis and also highly cost materials. Okay, you can simply achieve a very high permeability using uh, a simple polymers, right? Non-polyimide polymers. Okay, and you can further optimize to get a better performance of perm salinity and permeability. Okay, how about their performance? Okay. This one is about CO2 and CH4 separation. This is basically for oil and gas industries. So basically, you can see this is clearly dominated by uh, the uh, uh, polyimide based carbon membrane. Okay, so there are vast opportunities for you to develop a non-polyimide formulation. Okay, or modified polymers formulation. Okay, so that you can provide a better cost-effective carbon membrane to be used in the industries. So we can conclude that based on this slide, that there are three main types of polymers being used in the development of in the field of carbon membranes. So the first is pristine, modified, and non-commercial materials. Okay, you can ignore the non-commercial materials. Okay, you can focus on the pristine and modified polymers. And then the polymers can further categorize into
polyamides and non-polyamides. Okay, both provide advantages and disadvantages in formulation and synthesis route. However, the performance are competitive against each other. We found that no polymers are superior against each other in terms of O into N2, 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 H2, N2, and CO2, CH4 separations. Okay, so we recommend that it's highly recommended non-polymers to be fully developed for highly competitive carbon membrane in gas suppression. So that's all for the presentation. You can always contact me, alright, through my email azan@usin.edu.my. Thank you very much.